Hey everyone, welcome back. Today's day 6 of my 30-day FAANG grind, and I'm solving 6 to 10 LeetCode problems daily, explaining them on videos, and sharing with all of you on YouTube. I'm Divya, by the way. I've interned at Massachusetts Institute of Technology, where my area of focus was in statistics and machine learning. Right now, I'm at top 0.3 on LeetCode, and like most of you, I love doing DSA problems. Previously, we have already covered problems based on sliding window, two pointers, prefix, and suffix based problems based on strings, and problems based on stacks as well. Today, it is all about binary search, which is one of the most versatile and powerful techniques in coding interviews. We'll go beyond just finding a target and solve problems based on rotated arrays, lower and upper bounds, and binary search on answers, and much more. In fact, the problem that we are tackling today is one of the problems of type binary search on answers. Before I begin, if this content is helping you out, smash that like button, hit subscribe, and let's go. The problem that we're tackling today is 875 Coco eating bananas. The problem states that Coco loves to eat bananas. There are n piles of bananas. The ith pile has piles I bananas. The guards have gone and will come back in h hours. Coco can decide her bananas per hour eating speed of k. Each hour, she chooses some pile of bananas and eats k bananas from that pile. If the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. Coco likes to eat slowly, but still wants to finish eating all the bananas before the guards return. And we have to return the minimum integer k, which is her rate of eating or her rate of speed, such that she can eat all the bananas within h hours. These are the constraints and these are the examples. Cool. Let us go to our dashboard and we'll try to investigate and find an optimal solution for this problem. Okay, so we have been we have been given piles, and these are the number of piles of bananas that are present in our store, and this is the h hours, which denotes the guard has been went away for h hours, and they will come after h hours. And right now, our objective is to find k, which is the rate of eating speed for Coco. I will just call k as rate of speed for Coco, such that she finishes eating all those bananas in the piles. And this k, it should be the minimum value that we have to return. Okay, cool. So what are the things that we have been given over here? We have the piles, which denotes the piles of the bananas, and we have a timeline. Cool. Now, our rate of eating speed k, it will depend on a few factors, essentially on two factors. The first one is on the number of piles and the value of each piles. Second one is on the h time, the guard's time, the time the guard has been went away. Okay. In this case, since we do not have been given a direct sample space for k, we will have to determine the sample space for k. By sample space, I mean the range for k, the lower and the upper bound for k, and we have to search within that fact range, and we have to determine the minimum value within that range. How do we do that? First of all, what can be the minimum eating speed Popo can have per hour? It cannot be zero because that will make no sense. So essentially, the minimum is eating speed for Coco per hour will be one, which means Coco can eat one bananas per 1 hour. All right. But what will be her maximum eating speed given these are the piles of bananas we have? Can it be infinity? Can it be 20? Can it be 100? Can it be thousands? Can it be 11? Can it be 12? Can it be 13? What should be the most appropriate speed, the higher bound of the speed for this specific example? Let us take a look. What if her eating speed is 20? Does it make sense? Let us see. If her rating speed is 20, let us look at the maximum value. What will happen in this case? She will finish eating 11 bananas, but she will still have some amount of time left because her eating speed is 20 bananas per hour, and currently she has just consumed 11 bananas, right? So she will still have 9 bananas amount of time left. What will she do with 9 bananas of time left? Nothing, correct? So you'll just stay on this index itself as it is stated in this problem statement, okay? So what should be the most viable highest speed for Koko in this specific case? It should be 11 because if her eating speed is 11 in this specific case, then she will be able to consume the 11 bananas within 1 hour. And once that is consumed, she'll move to this next part, which is nothing. And if her eating speed is 11, she will consume 7 bananas, but will still be left with 4 units of bananas amount of time. And again, she will just stay 4 units of time over there at that place. At this place, she will spend extra 5 units of time doing nothing. At this place, she will spend 8 units of time doing nothing. Okay. If her rating is if her rating speed is 11 bananas per hour, which is the highest in this case. So in some sense, essentially what we have done is we have set a boundary for our eating speed, where the lowest eating speed she can have is 1, and the highest eating speed she can have, or the rate of eating speed she can have, is 11 for this specific case. Awesome. Now, let us look at this diagram. What does it tell us? It tells us, hey, there will be cases. If her eating banana speed is very low, she might not be able to finish all those piles within H hours. But if her eating banana speed is very high, she will be able to finish those bananas within H hours, which will lie in this range. But what we have to return in this range? If her eating speed bananas lies in this range, which value should return? Should we return this value, or some other arbitrary value? Our objective is to return an eating speed such that she consumes all those bananas within H hours, but her eating speed should be minimum, which will be this one, correct? Not this one, but this one, because we have to return the minimum. So now that we have defined the scope for her eating speed, let us try to solve the problem. Let us try to walk through the code and see what is going on over here. Now, we have low and high. These two are the factors or the boundary for her rate of speed of eating bananas. And what do we do next? We compute the value of mid. Mid essentially, let us suppose it points at this part. It tells us, hey, right now she is eating at this speed, which is mid, which is bounded within this two boundary. And it tells us, hey, currently Koko is eating at this current speed. All right. If she is eating at this current speed, can we find the total amount of time she will take to consume the entire bananas? Let me repeat that again. If mid points at this part, it means Koko is currently eating bananas at this speed. All right. If Koko is eating bananas at this speed, will she be able to finish all those bananas within H hour? The answer is yes, because it is in this region. If she is able to finish eating all those bananas within H hours by standing at this point, by having the rate of speed of this nature, of this magnitude, can we able to determine the total amount of time she will take if her rate of speed is something over here? I will repeat once again. If Coco's banana eating speed is this, can we use this array to determine the total amount of time Coco will take to finish eating all those bananas? Can we do that? And the answer is yes, we can do that. And for that, we have this function, compute function, that takes a parameter speed, which is essentially this value that we were indicating initially, which tells us the rate of eating speed of Coco per hour. We have this speed parameter and we have required time as 0. Now, what do we do? For every single pile in the array, we scan them and we take the ceiling value of that. It is simple math. And we add the time taken in the required time, which is initially assigned to 0. And once we scanned through the entire piles of the bananas, we'll be left with the total amount of required time that Coco took for a specific speed. In this case, the speed was pointing over here. So yes, we can compute the total amount of time that Coco might take for a specific speed of her eating speed by scanning through the piles and making a simple ceiling division and then adding that need time in the required time, which will give me the total amount of time Coco took if her initial rate of eating speed is something similar to this nature, we will get the required time for Coco, okay? And once we find the required time, what is our objective? Our objective is if we does if we do indeed find the required time, that time it must be within the H hours, correct? Now we ask ourselves, hey, if Coco finished eating the bananas within H hours, what does that entail? It tells us number one, we were able to eat all the bananas. Number two, we were able to eat all the bananas within H hours. Okay. And if this statement succeeds, it means standing over here, we were able to finish eating all the bananas, and there is a chance that we have still a chance that we have smaller speed on the left of it that will still accomplish the same the same task of eating the bananas within H hours. So what we do, I move my high pointer to mid minus one. If mid was over here, I discarded the scope, moved my right pointer to mid minus one to scan the remaining parts, okay, where Coco can finish with a minimum amount of time than the earlier one, so that she finishes eating all the bananas within H hours. And before I do that, I make a comparison between answer and the mid value. Mid value over here is what? It is the mid speed, the rate at which Coco was eating, okay? And this mid value, it is bounded within the lower rate and the high rate of her speed, okay? And we make a comparison, store the minimum value in the answer, move the high pointer to mid minus one. But if somehow, let us suppose, if our mid was pointing at this part, what does it mean? If mid is pointing at this part, it means essentially that Coco was even though able to finish eating all the bananas, but she was not able to accomplish this fact within H hours, which means she took time more than H hours. And if her eating time surpassed eating more than H hours, it means left pointer, it must move to the right. So that our space, sample space, it becomes much more concentrated. And it is required because only then we will be able to find such a rate so that she'll be able to eat all the bananas within H hours. That is why we are moving low to mid plus one. And once this loop is exhausted and ran, we can return answer, which will contain the actual answer for our case. The time complexity for this thing is order of n, which is coming from this function, order of log n, which is coming from over here, and the product of both of those things. And the space complexity will be constant. So yeah, that was all there was to this problem. Let us go to the dashboard and we'll try to submit the solution. I've already submitted a solution, so I'll just copy and paste my code and I'll just run it down and we'll see how it goes. And as you can see, the test cases has been accepted. It has passed the test cases. So yeah, that was all there was to this problem. I hope you understood my explanation. If you have any doubts, please ask me in the comments and I will help you out there. Bye-bye.